Hello everyone, this is Oscar and today we're going to be working another problem from Calculus 3. This problem is asking us to determine whether or not the vector field is conservative, and if it is, we have to find the potential function. Okay, so first of all, we're given the original function of x of y is equal to, here we have the x component and the y component. This could be just rewritten. I like to write them in vector form. So this is equal to 4x plus 5y, comma, 5x plus 8y. Okay, to determine if the vector field is conservative, first we're going to have to assign this x component as p. This is more of a notation thing, and this second part as q. And what we want to do is say that py is equal to qx. Therefore, if these two are equal to each other, then the vector field would be conservative. So py is p with the partial derivative with respect to y, and q, we're going to want to take the partial with respect to x. So py is equal to partial with respect to y, this would be 0, and then this would be derivative of 5y is just 5, and then qx is just equal to partial derivative of 5x with respect to x is just 5, and then over here is 0 because there's no x, and as we can see 5 is equal to 5, so that's correct. So that means they are conservative. So now it says we have to find the potential function. Okay, so let's just clear up some room here. Okay, so the first step here is this was our original p. This is saying that this x term right here, if we take the integral of that, we will have at least one part of the potential function. Because if we have the potential function and we take the derivative, we will get the vector field. So with that logic, our original potential function, if we take the derivative, it would be df dx is equal to whatever we have here already. So that's just a notation thing, and that's the first step of solving this problem, that df over dx is equal to 4x plus 5y. So now what you want to do here is you take the integral of both sides with respect to x only, and then this would give us df is equal to 4x squared over 2 plus 5yx. But the trick here is that since we took the integral with respect to x, there could be some type of term here that does not have or does not include an x, but we want to write this as h of y. This is saying that since we took the derivative with respect to x, there might be some term of y here that doesn't have an x term, and it could be any term, so we just write this. Okay, so now we have this new equation. This is our new equation, and so our next step is we want to do this new equation, but now we do it partial derivative with respect to y. This would be the next step of solving. The derivative of 4x squared over 2 with respect to y is 0. Plus here we have derivative of y here it's just 1, so this would be 5x. And then we would have 5x plus the derivatives of h of y would just be h prime of y. And then this is our new equation. So now, this is similar to the form, this right here is similar to the form we had over here. And we assign that the function with the derivative with respect to x is equal to here. And then that means df over dy would have to be equal to this. So what we solve for here is, I'm going to start writing over here is 5x plus h prime of y is equal to, our df over dy over here is 5x plus 8y. So if these are equal to each other, this would cancel, and we'd have h prime of y is equal to 8y. Now, to solve what h of y originally equals, this would give us our missing equation here of our, this is going to be our, it's going to end up as our potential function. So if we take the integral of both sides here, we'd have h prime of y, not anymore since we take the integral, would just be h of y. And this would be equal to, this integral sign actually has to be over here. And it'd be 8y squared over 2. And that's just 4y squared. So this is our h of y that we just solved for. So we could just plug this in over here, 4y squared. And that would give us the actual potential function. Here is our potential function. It's just simplified, would be 4 over 2 is just 2x squared plus 5yx plus 4y squared. And that would be our potential function. That is the final answer to the problem. So yeah, you just have to remember, we first have to determine if it's conservative, and then to find the potential function, we first set this term equal to df over dx, take the integral, and then we get this, it's like an arbitrary constant h of y, and then we actually solve for h of y by setting our df over dy equal to this. And then you solve for h of y, and this would be the potential function. I hope this helps you guys. Good luck solving any more math problems.